Curious about what the square root of a continued fraction is like? In this video, I will explain why this is true. So to start off, I'm going to recall the following rule here. So I have two variables, a and b, and I try a minus b times a plus b. So what I do next here is I will multiply them out. So I get a times a. This is a squared. Then I get a times b, which is plus ab. And then I subtract this. This is minus ab. And then I get minus b squared. So these two terms cancel. And what I'm left with is a squared minus b squared. This difference of squares. And so to summarize, the difference of squares rule is a minus b times a plus b equals to a squared minus b squared. So next, what I'm going to do here is I'm going to make some substitutions. I'm going to let a equal to the square root of 2, and I'm going to let b equal to 1. So making these substitutions, I get this. Square root of 2 minus 1 times square root of 2 plus 1 equals 2 square root of 2 squared minus 1 squared. Evaluating this some more, we get 2. So square root of 2 times itself is 2. And then we get 1. So 2 minus 1, and this is 1. So what we get is square root of 2 minus 1 times square root of 2 plus 1 equals to 1. My next step here is that I divide both sides of this equation by root 2 plus 1. So what I get here is root 2 minus 1 equals to 1 over root 2 plus 1. Next, I'm going to add 1 to both sides of this equation here. So what I get here is root 2 equals to 1 over root 2 plus 1 plus 1. I can rewrite this somewhat. So I get 1 plus 1 over 1 plus root 2. So the working equation I'm going to have here is this. The square root of 2 equals to 1 plus 1 over 1 plus root 2. And I'm going to use this equation here a lot. Now here, notice that I have this number appear 2 times. So I'm going to pay attention to this number here. Because this number here equals to this whole expression, I make the first substitution. That is, I'm going to write 1 plus 1 over 1 plus this thing right here, which is this thing over here. 1 plus 1 over 1 plus root 2. So let's simplify this. So what I get here is I get 1 plus 1 over, and I have these two ones here, so I get 1 plus 1, and this is 2. So I get 2 plus 1 over 1 plus root 2 over here. Now I repeat this process again here. So I'm going to pay attention to this number here, and I'm going to use this equation again. So what I get here is 1 plus 1 over 2 plus 1 over 1 plus now the expression. 1 plus 1 over 1 plus roots 2. Now I'm going to simplify this again. So notice here I'm adding 1 to 1, so I get 2. So what I get here is 1 plus 1 over 2 plus, right here, 1 over 2 plus 1 over 1 plus roots 2. Now, there are a lot of 1s and 2s going on here, but eventually there'll be an emerging pattern. So I can keep repeating this by looking at this expression here, expanding it, and then adding more numbers. So the emerging pattern is that if you repeat this process an infinite number of times here, then I'll get this as my answer, or the root of 2. I get that 2 roots 2 here equals to 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over, and so on. So we get our first equation here, that roots 2 equals to this expression here. So the next step can be found in one of my videos. Can a continued fraction be an integer? A link to this video is found in the description for this video. In that video, I explain why this is true. That 1 plus 2 over 1 plus 2 over 1 plus 2 over, and so on, equals to 2. So what I'm going to do is I'm going to combine these two equations together. How, you may wonder? Like this. So first I consider this. So I look at the square root of this continued fraction. 1 plus 2 over 1 plus 2 over 1 plus 2 over, and so on. So this continued fraction inside here equals to 2. So I can write this as square root of 2. Now, this number here equals to this continued fraction. That is this 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over, and so on. And so this is the equation that I wanted to show. So to recap, we used difference of squares and some college algebra to show that the square root of this continued fraction equals to this continued fraction there. There you have it. That is your answer. If this topic is interesting to you, please subscribe to my channel.